Great. Okay. Thank you very much, and thank you for the organizers for inviting me today. You really have stacked the cards against me. I'm following Calvin and Nicole at the end of day 2 of a very informative conference, and we had those fabulous cabbage rolls and pierogies, and I'm sure everyone's still digesting a great meal. So with that, let's get to an interesting set of circumstances that we encountered in 2023 in September and October and November. I have to also acknowledge a number of co-authors, and I'm just realizing that I have forgotten to add Nicole's name. Apologies, Nicole. We have a number of people who've been involved with this project, and a lot of it, in fact, involves some very excellent technical support in our lab through Shelby Dufton, who is here in the audience. I also want to acknowledge the fact that we have a couple students here who also, numerous students contributed to this project. And then, of course, our people down at Oregon State University, also our Ag Canada taxonomists who have proven to be very pivotal in helping us figure out what was going on. So let's get to it. September 2023. So not every creeping red fescue producer was facing a situation like this, but there were a handful. And one thing that happened in September was that we started to get calls. And our calls were starting to come from the people you were calling. And that is, of course, Calvin Yoder and Doug Thiessen at Foster Seed and Feed. A number of stands of creeping red fescue, particularly around Spirit River, out towards Valhalla, down around Beaverlodge, Hythe, were exhibiting symptoms like this. Now, in the fall, you ideally do not want your creeping red fescue to be looking this yellow, this brown, and in fact having loose sod that you could lift up. So not an ideal situation. This is an example of a field that was out towards Silver Valley. This is an interesting field that we'll talk more about, but here's another field. And of course, we all understand that creeping red fescue, as it goes into overwintering, can be at various stages or age, but another situation where there was a lot of yellowing, lots of browning, certainly not ideal conditions given the fact that we had a fairly open, very dry, but fairly open fall. So those stands precipitated a lot of activity, and the initial crowns that were dug up and brought to us by Calvin and Doug, and many growers even in this room, we actually were able to do some diagnostic identification. So this is basically the very sophisticated work that has to be done. It's incredibly necessary though. The crowns basically have to be pulled apart within about 48 hours for us to see what's actually in and feeding in the crowns or causing the damage. So it's literally a very sophisticated container where we're putting the crowns and dissecting them by hand very carefully. It's pretty painstaking work, and I have to give a huge credit to our staff because it is painstaking. So the interesting thing is we started to pull these apart, and this is very reminiscent already to me because we had a cutworm outbreak back in 2000 that was very serious, affected huge numbers of acres in the piece, not just our seed producers, but also our pastures. And suddenly we had crowns that were looking very, very similar. So the picture in here, it's basically a crown with the grass on top and the soil that you're looking at. And the reason it's really interesting to us is the fact that we were starting to find larvae in there. Now, I don't have a pointer, but I did try and put a red ring around the larvae that was actually feeding just under the soil surface. So essentially, most of these larvae, when we are pulling these crowns apart, and it is the royal we, when we pull them apart, these larvae are usually within the top 4 to 8 centimeters below the surface of the soil. They're usually embedded right in the crown, and again, this is very consistent with what we saw with cutworms, and in fact, cutworms were there. So again, on the one side, it's the same crown, and on the right-hand side for you folks, I've circled the red area where a very nice large larvae is in there feeding. Again, this is October 2023. The other interesting thing is, oh, sorry, I'm on the wrong side. These are 2 separate crowns, but same thing. There were not just one type of larvae, and that was what was very concerning to us. As we started to pull some of these other crowns apart, and this is, I know from the back of the room, impossible to see, we were actually finding some very unusual weevil larvae. Now, as I said, we suffered a cutworm outbreak in 2000. I have pulled apart a lot of grass crowns, and in this case, it is actually me doing it too. But what we were seeing in these samples from 2023 were some very large weevil larvae. So at this point, enter Nicole Anderson, who happened to be around, and we were talking about these weird weevil larvae, and she had already told me a few years prior to this about their issues with bill bugs in Oregon. Huge, huge problem. It's a weevil, the larvae feed, and very difficult to manage. So of course, when we started to find weevil larvae in our crowns, it was not a great piece of news. At that point then, when we were seeing so many acres being affected, quite late in the fall, after a season that was very warm and extremely dry, the Forage Seed Association was able to come forward and put some resources towards a small project. We were very fortunate at the research farm to be able to kind of mobilize very quickly. And so essentially what I'm kind of talking to you about is a very short-term project that then was initiated from October 2023. Okay. So this will span basically the collections we did in the fall, collections we went back to the same fields in the spring, tried to follow it into the summer, and then this fall we've done some other survey. Okay. So this is an example of some of the larvae that Shelby in particular pulled out of some of the crowns in October. One thing that struck me right away was the fact that there was some high densities of larvae, but the other issue is that these larvae were very large. And large larvae in the winter, or pre-overwintering I should say, are a bit of a cause for concern because these are the individuals, and if they're very large and very fat and very happy, they usually overwinter very well. And in fact, many species of our cutworms, when they are very mature as larvae going into wintering, they then emerge into the spring and they start to actively feed quite quickly, and their feeding has to support a larger, more developed larvae. So of course, they eat more and very quickly, but it can happen very early in the spring. So we have a very interesting situation. We've got high densities of larvae, very mature larvae going into overwintering stands that were very very stressed from drought, but now also have this unusual feeding damage. Actually, I'm just going to go back there, sorry. So actually, the other reason I wanted to show this slide is we do have a cutworm right in the center of these larvae. However, the weevil larvae that we had never seen before are circled all around. The key characteristic of these weevil larvae is their sort of C shape. They do have a really nice little brown head capsule like a cutworm, but you can see how they really are shaped quite differently. So very distinct even as larvae, that we know that they are not cutworms. So of those crowns that we pulled apart, I forget that there's a screen down here. Essentially in the fall, because there were resources available to us, we were able to mobilize and get to 12 sites before the snow flew. You know, once the ground freezes, it's pretty hard to dig out crowns. So we managed to get to 12 sites. We sampled between 8 to 13, and most of the sites, actually over half, are about 15 crowns per site. We selectively chose sites where there were problems. So these were sites that we could easily access within traveling distance, but at the same time, Calvin and Doug and the producers who had been working with them and identifying problems, those were the sites that we tried to prioritize because our goal was to get larvae to identify. So I know this is a really hard bar chart to see from the back, but essentially what we were finding is that we had 6 different groups of insects as larvae feeding in the creeping red fescue. Now to you, that's going to sound like a huge problem. It isn't normally, but what is concerning is the fact that we had very high densities. So when we stack all of the larvae that we're finding per crown, and we actually go and do an average for the number of crowns that we collected from each of the sites, which is actually one stacked bar here in this chart, we had some very high densities. Now, the big thing is, most of our creeping red fescue, and in fact all of our grass seed growers, routinely deal with solid webworm. So that's the bottom portion of a gray bar. So yes, some high densities, but sod webworm can show up in high densities, but they are a very small insect, much smaller than some of our cutworms. So it actually takes more of them to feed and cause equitable damage to what a cutworm will do. It's not that they're no problem, it's that we're not usually in a huge panic, except at a couple sites we saw some very unusually high densities of them. So my experience with cutworm outbreaks is that when we find sod webworms, we immediately know that we've got cutworms. These are Lepidoptera and larvae. They're somewhat closely related. They all overwinter as larvae. So if one group is doing well, typically we're also looking for similar groups. Sure enough, there were cutworms. So the portion here on these bars would be the glassy cutworms and the yellow-headed cutworms that we were recovering. These are our key species that we suffered the huge outbreak in 2000 across the entire Peace region. So again, a bit of a cause for concern. There weren't high densities, but the larvae that we were retrieving from these sites were very mature. They were long, they were robust, perfect for overwintering. Okay. The worrisome part here is the black portion of these bars. Okay. What was very surprising is those weevil larvae that we started to pull out of some of these initial crowns, they weren't just at one or two sites, they were at every site. Okay. So then, in the back of my mind, I'm in a panic that it could be a pest that Oregon deals with routinely. We had to figure out what they were. And then one other site, one of these 12 sites, had a fly larvae, again, that we've never seen. And that's the blue bar that you would see on the right. Now, all of these sites, basically, I'll read them across so you don't have to struggle and read. We're talking about Bonanza, near Fourth Creek, Homestead, Hythe, Napa, and near Spirit River, okay? So that's the geography that was definitely suffering some of the biggest issues in terms of the damage. So when we look at these portions of the bars, and because I don't have a pointer, again, the black portion of the bar that I have the red arrows beside are where we are finding the weevil larvae. Some high densities of them, but again, what were they? So again, it's the C-shaped larvae, very mature. The fly larvae that we were finding that we had never seen before, actually, Shelby, to her credit, excellent at keying out, had identified that these were from the family Bibionidae. Well, that group includes March flies, okay? March as in the month of March. That's when traditionally people see March flies emerge as adults, and March flies are a historical and well-recognized pest of turf and sod. Not in the Peace. This is literally the first time I've ever seen it in my 20-some years. One site only, too, so very unusual. But the fly larvae are looking here in the top right corner very much like a cutworm, except they have tons of spikes coming off of every segment. So a very unusual insect larvae, even by my standards. Well, the really cool thing is we were able to take those larvae, brought them to attention to someone like Nicole, who works with a wonderful entomologist, Navneet Kaur, out of Oregon State University, and Navneet was willing to barcode the larvae. Now, this is a big deal because otherwise we would have to rear and overwinter those larvae to get adults so we could actually confirm the identification of those individuals. The DNA barcoding offers us an opportunity to compare against existing barcodes to hopefully associate some sort of species identification. And luckily for us, Nicole and Navneet were willing to do that. So these really crazy fly larvae that we had never seen before, we actually shipped the larvae, preserved, all dead, very nicely sealed up in ethanol, to our colleague who was able to do some barcoding. The really cool thing is she was able to get them down to a genus that looked pretty solidly like it would be something that would be a match that is actually a pest in Oregon. Subsequently, what's been done as a result of some of the field work that we did in 2024, we were able to actually collect adults from these same fields that we were very confident were from this same group, and we were able to send those specimens to our taxonomic experts at Ag Canada in Ottawa. There's a national identification system that we as scientists have access to, and the taxonomists are international experts. The really cool thing is the barcoding got us really close, even suggested a good species match. The neat thing is the taxonomists now, literally 3 weeks ago, were able to confirm that it maybe isn't quite exactly what the barcode says, but a very closely related different type of march fly. So here we have a very unusual situation. Sure, it only showed up so far in one field, but at the same time, now we've been able to figure out very quickly within a few months what it could be, and then confirm it basically 12, 13 months later. Now, as we look at some of this, it's kind of interesting because our next effort was to wait for the snow to fly, wait for it to melt, and then the following spring try to get back to all of the fields that we actually assessed. The interesting thing is that almost half of the fields that we did assess in October were so damaged and so unhappy in the spring that those producers actually chose to plow them. This is nothing new, as you all recognize. However, it meant that we were not able to necessarily return and follow populations in the same fields. About half of the bars that you're looking at from this spring assessment in 2024 were actually repeat returns. We were able to actually follow a few new sites. The interesting thing there is that we actually did find the fly larvae again in the spring at a second site near Homestead. So not only did it show up at the same site in Spirit River in the spring, it actually did show up in some other geography. And again, that's the blue portion of the bar. You can see in the spring, though, we have very different densities, okay? And this is very true for many insects. This is why fall monitoring for a lot of these insect pest species isn't very reliable, because they also suffer overwintering mortality. So in fact, some of these sites had much lower densities. However, they were definitely larvae who were still progressing in their development. So, just like the flies, what we did with the actual weevil larvae when we first started to collect them at all of those sites, we were able to preserve them as larvae, killed, preserved. Navneet was again very kind and generously offered to do the barcoding so that we could try and figure out what they were as larvae in November of 2023, rather than waiting for the full year for them to develop in the field and for us to get adults. Now you'll remember in entomology, many of our larval stages don't carry enough characteristics that we can actually assess them or tag them to a specific species. In fact, we always really need to rely on the adults, and that is what it looks like. It turns out that this species is actually associated with cattails. However, clearly, they are in a number of sites. They're very clearly associated feeding on the root material, and they actually have the further indignity of leaving all of their poop exactly where they're fed, and we know they're feeding on the creeping red fescue because there's poop right where it's clipped. Pretty handy in some ways. It's actually a fairly large weevil, okay? 6 to 10 millimeters long as an adult. We tried to put out some emergence cages. I would have liked to try and put out more, but we just didn't have the staff in place to do more sites, to do maybe slightly longer periods. But we actually were able to collect a few of these adult individuals. And as I just said, we need the adults to really start to compare morphology and really tightly associate a species identification. And so those specimens, when we did get them, they were sent to Ottawa again to our taxonomic experts. The key thing here, again, I've highlighted where those weevil larvae are in the crown. And remember, we've pulled the crown open, but essentially they are still sitting really in the top 8 centimeters below the soil surface, but right in the middle of the crown. They are very difficult to find. And of course, the red rings help us identify it, but otherwise it is very tricky. I have staff with really good eyes. Okay. So the interesting thing with the barcoding is that Navneet was able to get this right down to species level. And in fact, the taxonomists in Ottawa, when they compared the morphology, they confirmed that is definitely indeed what it is. It's Turnatoris bimaculatus. It doesn't really have a really super cool common name, but it is associated with cattails in the literature. So why is it in the creeping red fescue, you're going to ask me? And to be honest, I can only speculate from this point. So I've talked to you about what we did in the fall of 23, the summer of 2024, and into the spring, well, spring, summer. Who typed that? At any rate, so then this fall. The original plan in the project was that during the summer, we would try and return to those same sites we assessed in the spring. We would actually go look for damage and maybe potentially look at yield. Well, the good news of this story is the fact that there was really no damage evident. In fact, there was so nothing in some of these fields that it wasn't even worth trying to collect yield samples that essentially would show very healthy, vigorous yield. So instead, we followed it through to the fall. Now, these are not the same 5 sites that we've been able to assess from the start, from the word go. However, these 5 sites, it was actually a really great news. So you're looking at the same chart, the same y-axis, so we're comparing densities against densities. Very low densities. We are still finding some of the weevil larvae at multiple sites. We couldn't find any of the fly larvae, but keep in mind, this is a very small sample size of only 5 sites. These are based quite close to Hythe, Valhalla, and towards Spirit River. So again, it's some fairly narrow geography. However, I took this to mean that we were in a much better situation, particularly because we didn't see yield damage. So again, the why, and really at this point, it's a lot of speculation. The weevil larvae do have me very concerned because the fact of the matter is they were in all of the sites on a year at high densities, and we know that it was a hot and very dry year. I'm pretty confident, let's put it, in speculating that the temperatures and the precipitation and the dryness that we've been experiencing these last 2 seasons are probably contributing to the fact that this little weevil has decided to do a bit of a host shift. Perhaps there's just not enough cattail to sustain them. We don't know. But here's a good example. This is 2023. These are the growing, let me try that again. The 2023 growing season mean temperatures. This map doesn't look spectacular, but there are areas of the piece where we are on average kind of sitting at that 1.5 degrees Celsius higher than what we've seen in the past. And in fact, the 30-year mean temperature across the prairies is, for comparison, 13.9 degrees Celsius versus 16.5 for the whole entire prairies. So we've had a few years, starting in 2023, where it's been a bit warmer. Add to that our precipitation levels. I think all of us back in 2023 were very nervous about how dry it was. It was exceptionally dry. The red on this map showing the mean growing season precipitation, it was showing some pretty scary numbers. Of course, in 2024, then it did start to rain in certain parts. But this is actually looking specifically at the piece. We have colleagues with the Prairie Crop Disease Monitoring Network who have pulled some of the data from 2024. This is the growing season cumulative rain for the Peace River region. It is unbelievable how close it's following the borderline. But it's also interesting to me that where we're finding some of these weevil larvae really does correlate quite closely to where some of these red areas are for rain. It's dry. Okay. For comparison, as a percent of normal over the 30-year average, it's even more dry when you look at the data. This would be pulling just the weather data from May 1st to October 31st of 2024. And right now, that's a scary map for us to look at. So let's just instead look at the average growing season temperature for 2024. Again, we're seeing some temperatures over these last few years that are higher than average. We very much think that this is part of what's contributing to these weevils moving into the creeping red fescue. That is not great news, because what that means is that it's maybe a pest that we have to be more careful, more vigilant, and be watching for. And of course, that's even scarier because this is compared to climate normals, so we'll just skip over that. I think in terms of the outlook for 2025, what we saw from the fall assessments that we did, and also looking back to the fact that we weren't able really to see any yield damage in fields that did have larval feeding activity, to me that's a good news story, because it suggests to me that hopefully we have very low populations in most of these fields, and that this spring there's probably very little out there. However, insects always have a very bad habit of showing up when you least expect it, and the bad thing is as soon as you say it's probably not going to be this, they happen to always prove you quite wrong. At least at this stage, we know that we have fall overwintering larvae, low densities, but the other good news there is that some of those larvae, in fact the majority, were they were less advanced in their maturity. And the good news there is thin, weak larvae are usually the first to suffer from overwintering mortality. So we're going to hope that that's exactly what's going on out there outside. Okay. I do want to emphasize though, it's a small sample size. We did the best we could with the resources we had and the timeline available. In-field monitoring in the spring is going to be key. I can't get to every one of your fields, but certainly please be really mindful. We already are seeing some pretty warm temperatures at a very fast melt. March isn't done yet, but at the same time, in-season in-field monitoring, even by late April, would be something worth doing. I would say to you too, you've got to anticipate, as soon as the ground temperatures are anywhere around 2 degrees Celsius, we fully expect these larvae, because they overwinter as larvae, they're going to be able to be active and starting to feed. So that's why you need to be vigilant at that time, or at least start to be looking around. I cannot emphasize this enough, because with cutworms, it's always the same situation. You have to scout areas that are slow to grow, that they're failing to green up, or anything that's browning off, and if you have loose sod, you need to get into the green material adjacent to it and start to look around in the crowns. It's the same with cutworms, bird activity. Anywhere that you see flocks congregating, birds are usually very happy to find the cutworms and eat them. You want to encourage that, but it's probably best to also take a look. Okay. I think the key thing is we've had a fairly open fall. It is very dry. I think everything depends now on the next couple of months in terms of how spring unfolds. But you know, the best plan is always to plan for cutworms and expect sod webworms to be there. But then also we need to start watching more carefully for these weevil larvae and being fairly attentive. Again, the good news here is that we've been able to confirm both through the barcoding and the taxonomist looking at the adult specimens that we don't have bill bugs, so this is great news. We do have something else going on though in our fields, and I think that's very important. How am I doing for time here? I have a couple more minutes? Okay, then if that's the case, then let me just jump forward, because some of the cutworm stuff that we do need to talk about, I fully expect that cutworms are going to be one of our big issues. When I say late April, it's really key, not just for the weevils, it's going to be also for cutworms that we know we need to expect in our grass seed crops. Okay? Mild winters with good snow cover offer sometimes really excellent overwintering habitat for our cutworms. The key thing with this, and I've shown it to you folks a few times, some of these cutworm species are overwintering as larvae. They can be active as soon as the ground temperature increases enough, and it's microclimates, okay? They're overwintering in patches of field that are going to probably warm up fast, but really, we're talking like late April, early May. And if it's as dry in the soil as what the precipitation maps would suggest from last October, that means we've got some stands that are maybe not very happy unless the snow melt is really favorable, okay? And I think probably I should leave it there because that's definitely more than 2 minutes, okay? Thanks very much, everybody. And I want to also lastly just thank all of the many producer cooperators. We can't do this work without the permission to access. And so many of you have been very generous over the years. We really do depend on it, and thank you for that.
Token of our appreciation.
Yeah, so I don't know if you can all hear it, but Joanne's just saying that they have identified the same weevil in meadow, brown, in Saskatchewan. Do you, oh, Fescue, sorry. Sorry, the light is like crazy right here. Yeah, so this is the interesting thing. We've had some extremely different weather patterns the last 4 or 5 years across Western Canada. During my career, I've seen 7 different invasive species set up and established. And I mean, the red clover casebear is one of our prime examples. Wheat midge here in the Peace River region. You know, it's not an accident these things are happening. And I think this is where producers have to be very aware. You know, these insect species are bioindicators of change. They're reflecting what's going on, whether it's your agronomic Technology is changing, practice is changing, but it is clearly also associated with the environment. And I wish we had more information about what's going on with them. We were thrilled to be able to get a species identification, shocked to see the host association in the past literature, but clearly they are in there and they are actively feeding. There's no question in my mind. So it's going to be, I think, another pest that we need to start to be more vigilant and watch for, and spring monitoring is probably the best thing. What's going to be good to manage it? What kind of density? Good question. It's interesting you're mentioning the density and how aggregated they were. 12 larvae in a crown, I think is what you said. So a few of the crowns that we definitely brought in, that's how they seem to be. So with those weevil larvae, what's probably happening is a female is laying the eggs, which gives rise to the larvae. If you lay your eggs in batches, you're going to have batches of larvae, okay? So that's probably what's going on. But given that, you have to expect that you maybe have a very aggregated population, which means sample in more spots of the field. Because your chances of encountering these guys depends on you sampling at least 10 different spots in a field. So it's a question of doing more to detect something that's maybe very hard to find, but may be in very high densities. So yeah, lots of work still to do, and it's kind of a cool story from my point of view. Not so cool for you folks, I know.
Okay, any other questions? I think that's enough good news for one day. So yeah, we'll break now for coffee, and we'll reconvene in half an hour.